10.7 is going to be surface area of a sphere, because we can calculate surface area of a rectangle, triangle, all those types of things, even a prism and all that. We have those shapes. But we never talked about what happens when a shape gets a bend in it, like a sphere, right? So today will just be mostly surface area and a bit of volume. Bring the mouse over here. So the surface area conjecture that we came up with here is that the surface area of a sphere with a radius r is going to be 4 pi r squared. And remember, this is going to be area and not volume. We'll have kind of different equations. Look at this. So example number 1, sphere has a radius of 7 centimeters. What's the surface of the sphere rounded to the nearest 10? So we'll have, using our equation, just 4 pi times our radius, which is 7 squared. So then we plug that into our calculator, and we get an answer that looks like 615.8. And then something important here as we look at this is that this is area, not volume. So our units should be centimeters squared, right? Cubed is volume, squared is area. So that's something to keep in mind there. Hopefully that doesn't seem too bad. We just plugged it into an equation and then got our answer. Whoa, dropped my pen. All right, find the surface area and volume of a hemisphere. So we're looking for both surface area and volume. So we'll start with surface area. Well, hemisphere, that's half of a sphere. So we'll need to take our equation for a sphere, which is going to be 4 pi times our radius, which is 4 squared. But then it's only half of a circle, right? So we need to make sure that we either divide the whole thing by 2 or multiply it by 1/2. So now we've got our equation, just taking half of our sphere, and we multiply all those things together, and that comes out to be about 100.5. And then this is inches. I did that last period. Inches squared, right? Because that was our surface area. And on questions where there might be 2 of them, you need to specify which one is which, right? Because otherwise I might take it as volume instead of surface area. And that would be kind of disappointing, right? Because there will be a slight difference in these. So I have to think back. Now I'm looking for the volume of my hemisphere. Well, the volume of a hemisphere is going to be half of the volume of a sphere. My equation for the volume of a sphere is 4/3 pi times radius cubed. And it's a hemisphere, so it needs to be multiplied by 1/2. So I take 1/2 times 4/3 pi 4 cubed, and this one comes out to be about 134.0. And this is centimeters cubed. And you look there and you said 134.0. Do I really need to write the 0? No, but yes, depending on what we're doing, but no for me. It just shows there that that was like 133.99. So then when I rounded it, it went to 134. So I did use that 4th decimal spot there, where the decimal, it just doesn't exactly show up there. So that is that. Any questions on this page? No questions? All right, moving on to the next one. We got this shaded region here, right? And it's asking us, what is the surface area of a sphere where the area of the circle is 30 pi feet squared? Right, so they gave us an area of a circle, and we're looking for the surface area of the sphere, so the big thing in total, right? They gave us this. We're looking for this. Well, to find the surface area, we need a radius. So we're trying to think, okay, how can we relate area to radius? Well, I know my area is 30 pi. And the area of the circle is pi r squared. Right, so that area would be equal to pi r squared. Well, going backwards, I can figure out what the radius is using this equation right here. So I divide both sides by pi and get 30 equals r squared. The next step would be to take the square root of both sides, right, to get rid of the r squared. So I get the square root of 30 equals r. And so now I have a radius. Once I have a radius, I can use that to find the surface area of this sphere. So I do surface area is 4 pi my radius, which would be square root of 30 squared. When I square the square root of 30, I'm going to get 30. So then I can multiply 30 times 4 and get 120 pi. And then to make sure I got it in a decimal, I take 120 times pi, and I get roughly 377 feet squared, right? Because this is still an area. So then I used the area of a circle, worked backwards, found the area, or found the radius, used that radius to find the area of my sphere. Any questions on that one? All right. Moving on to the last example right down here. Say we've got a dome that looks like the one here. We've got looks like a quarter of a hemisphere over here, a quarter of a hemisphere over here. And we want to find the surface area of the dome minus the floor. And we're going to round that to the nearest tenth. So sometimes people build buildings like this. I don't know if you guys have ever seen one like that. I think they're kind of cool. But that would be our building, right? We think about what do we need here to find surface area? Well, to start, we can look at these two ends here, which looks like half of a hemisphere. If I have half of a hemisphere and I have two of them, I combine them together, I'm going to get one hemisphere. So I need the equation for a hemisphere. So 1/2 4 pi r squared, right? That'll give me the area of my hemisphere. Then I'm looking at the middle, the blue part there, which I want to name in blue, and that looks like a cylinder. Then we have to think back to the area of a cylinder. Well, there wasn't quite just an easy equation for this. We kind of put it together with some things. It wasn't just like 1/2 4 pi r squared. You can think back, it was 2 pi r h plus 2 pi, no, yeah, 2 pi r squared. You think, okay, well, pi r squared, that's the area of a circle. So 2 pi r squared, well, then that's going to be talking about the ends of our cylinder there, which would be kind of the bases, but we're not using those to find the area, right? Because those are inside the building, so we're not concerned about those. So what we do need is going to be the 2 pi r times height, right? So our radius times height. And so this will give us the blue will give us the surface area of the cylinder, and the green will give us the surface area of the quarter spheres on the end. And so what we need to do is add those together. Now that we've got our equations, we can plug in the numbers to figure out our answers. So we've got 2 pi, and I'm thinking radius of my cylinder. Well, looking at the cylinder, it says it's got a height of 4, and it's cut in half, so that means that that is my radius. And then the height, well, that's going to be the distance between the bases. The bases here are on the ends, and it says that that is 8 feet. So we found the equation that we need for the surface area of our cylinder. Then we move on to our quarter spheres, or our hemispheres. We'll have 1/2 times 4 times pi, and then we need our radius. Well, our hemisphere, kind of a rough, that's not going to work. I have to draw it different. That's our rough hemisphere right there. And what the distance across is, right, is this green right down here and this green over here. And so that would be our diameter of our hemisphere. Well, the diameter is going to be the 12 minus 8, right? And that gives us 4. But the 4 is not our or not our radius, because that's the whole distance of that hemisphere. So that's our diameter. To make it the radius, we divide by 2 and find that our radius is 2. So then we take that times 2 squared. And we can start doing the multiplication here, right? So I take this over here, 2 times 4 times 8, that's going to give me 64 pi, plus this side over here, 1/2 times 4 times 2 squared, that's going to give me 8 pi. So now I can plug that into my calculator to get a decimal, and when I do that, my answer comes out to be 22.6.1, and this is going to be feet squared. Pretty sure that's the correct answer. So is there any questions on that example?
Did you cut the cylinder? Did you divide the cylinder by 2?
No. That's a problem, isn't it? That's where that disappeared to. That's a great question, Gary. I did not divide it by 2. Oh, that's why the 2 disappeared. I need to be more clear on that. All right, so we should have divided it by 2 because we cut it in half, right, Garrett? So we should add the half in here as well. Thank you. First period's gonna get that wrong. So we should all have this divided by 2, which makes this 32. Which then makes my new answer 125. Still different from what I got the first time. 125.7. And this will be feet squared. There we go. That answer is wrong because I forgot to divide my cylinder by 2 because it's only half of a cylinder and not a whole cylinder. Now, is there any questions on that now that you've caught me slipping there? No questions? Hopefully everybody noticed that. Nobody noticed it first period. All right, then your homework here would be 547, 1 through 3, and 9.